Very good morning, Anandal. Today, we are going to see a problem on drawing the per unit impedance diagram. Already, we have seen a similar kind of problem in our previous classes. Today, we are going to see a problem with the reactances given. Okay, take down this problem. Obtain per unit impedance diagram of the power system shown in the figure. Choose the base quantities as 30 MVA and 10.5 kilovolt. So generator rating is given as 30 MVA, 10.5 kilovolt, and also subtransient reactance, that is X double dash, is given as 1.6 ohms. Next, the transformer ratings are given for both transformers are given as T1 and T2 as given as 15 MVA, comma 33 bar 11 kilovolt, comma that is reactance is 15 ohms. Refer to HV side that they have given clearly. Next, transmission line actual value is given as 20 ohm per phase. Next, load values they have given as 40 megawatt and 6.6 kilovolt, 0.85 lagging power factor. So this is the single line diagram given in the problem itself. That is generator that is connected to a bus and it is connected to a transformer one and again to a transmission line and again transformer 2 and to the load. Next, what is the solution? Yeah, the solution for first we'll take the generator because we are starting from left to right. So we are taking a generator G. Okay, generator. So Z base equal to base kV square divided by base MVA. Already we have seen how to derive this. If not, you go back to my previous classes and see this formulation and come back to this class. I'll give that class also in the description so that you can watch and come. Yeah, Z base equal to base kV square divided by base MVA. So here base MVA is given as a 10.5 kilovolts. So 10.5 kilovolt square divided by, sorry, base kilovolt. Base kilovolt is given as 10.5. So 10.5 square divided by base MVA. So base MVA is base MVA is 30 MVA. So, say for example, if the base quantities are not given, you can take the base quantities from the generated values. That is, whichever is getting started. So, basically, in power system, generator only will generate the power, then the process goes. So, you can take the generator value as the base values if it is not given. Okay, say for example, sometimes a generator also not given. So you can choose some common base values. Say for example, near to the 10 kilovolt or 11 kilovolt. Based on the generator ratings, you can choose. Obviously, generator ratings will be given. So if suppose the generator value also not given, or otherwise, if you want to choose the different base quantities, that also you can choose. But if you round off, if you choose the generator base value itself, then it is easy for you to solve. So in this problem also, we have taken the generator base value. So here it is, we are taken as 10.5 square divided by 30 MVA. So we are getting the value as 3.675 ohms. Next, we need to calculate the Z per unit given or Z per unit old value. Old value, that is nothing but X double dash divided by, that is in this problem it is given as X double dash, that is subsynchronous reactance. In some other problem directly impedance itself will be given. So here whatever given that we are taking. So that is given as 1.67. Okay, so it is given as 1.6 ohms. So with that we are taking this 1.6 J divided by Z base, already we calculated that we are taking here, that is 3.675. So by dividing we are getting the Z by per unit given our old values as J into 0.435 per unit. Next, the formula. The formula already we derived this formula. Z per unit nu is equal to Z per unit given into KVB given divided by KVB nu, the whole square into MVB nu divided by MVB given. Okay, or otherwise Z per unit nu is equal to Z per unit old into Z KVB old divided by KVB nu, the whole square into MVB MVA new divided by MVA old. That also correct. So in some other books it is given as old. So for easy understanding, we have taken this old values as given value. So it will be easy for you to understand. So given value already we calculated, that is J into 0.435. That is KVB given is 10.5. Whatever given in the generator value 10.5 kilovolt, and also base value also 10.5 kilovolt. Similarly, MVA given also 30 MVA and base value is 30 MVA. That is also given. So the same thing you can take. That is 10.5 divided by 10.5 the whole square into 30 divided by 30. So you can get the Z per unit new value as J 0.435 per unit. That is for the generate. Mentioned clearly, otherwise, while substituting at last, you'll be choosing the wrong values. So mention clearly. So Z per unit new is equal to J into 0.435 per unit for generator. Next comes the transformer 1. Okay, transformer 1 we are taking. Transformer 1 already given in the problem refer to the HV side. So refer to the HV side in the sense we need to take 33 bar 11 kilo. So this formula is a base equal to base kV squared divided by base ME. So base kV squared is 33 base kV is 33 because when refer to the HV side we are taking that value as 33. So 33 squared divided by base ME. Base MBA given in the problem is 15 MBA. So base MBA is given as 15 MBA for transformer. So for transformer it is 15 MBA. Okay, so that value we are taking over here. So next Z base is equal to just if you divide this, you can get 72.6 ohms. Next, Z per unit given value, that is old value is equal to Z actual divided by Z base. Z actual that is given in the problem is they have given us reactance. So whatever the value given, that we have to take. So in the transformer it is given as 15 ohms. So the same thing 15J that we have taken. So 15J divided by this 72.6, that will give you the 0.2 J. Next, we need to calculate the Z per unit new. Z per unit new is equal to Z per unit given into KVB given divided by KVB new, the whole square into MVA base new divided by MVA given. MVA base given. So here, how to calculate this given, KVB new value. KVB new value is equal to this 10.5. Okay, 10.5 is the base value. Okay, 10.5 is the base value. Already we have taken that base value into this into this 10.5. Yeah, here 10.5 into this 33 by 11. Okay, 33 by 11 is the rating. Whatever the transformer rating referred to the this HV side. So 33 by 11. Okay, so 10.5 into 33 by 11. If we are considering, say, there is a one formula is there. So KDB new is equal to 10.5 divided by A. So A is nothing but transformer ratio. Transformer ratio is what? 11 divided by 33. So if you multiply this 10.5 into 33 by 11, that also same. Okay, so the rating of the with respect to HV side is given as 33 by 11. So 10.5 into 33 by 11, that is 31.5 kilowatt. Next, you need to calculate Z per unit new. Z per unit new is equal to Z per unit given. Given already calculated, that is 0.2 J into KVB given. KVB given is, 33. Okay, 33 because primary side we had. So new value, whatever we calculated, that is 31.5. The whole square into MVA new. MVA new is given as 30 and the given value is 15. So 15 is given in the transformer, 15 MVA is given in the farmer, base value is 30. So that we have to take. Okay, so here it is, so 30 divided by 15. So while simplifying all these things, calculating all these things, we are getting the Z per unit new for transformer 1, we are getting as 0.439 J. Next for a transmission line. Next for transmission line. Because after your transformer 1, it is transmission line. So transmission line already the value is given. Actual value is given, that is 20 ohms per base. Already it is given. So that value is given. Now actual value is given. Okay. So now KVB new is equal to KVB given into LT side of the voltage rating of the transformer 1 divided by HT side of the voltage rating of the transformer 1. This is already we have solved a similar kind of problem we solved in our previous problem also. If you not able to understand, you just go back, because this is the formula already we solved some basic problems also. That also I will give you in the description. That video also you can watch. Next step, here KVB given is 33 kilovolt, 33 kilovolt with refer to HV side. Okay, so 33 into this LT side of the voltage rating of the transformer 1, that is 11. HT side of the voltage rating of the transformer, that is 30. So so KVB new is nothing but 11 kilo. Now Z base equal to base KV squared divided by base MVA. So base KV squared is 11 kilovolt. So 11 kilovolt squared divided by base MVA. Okay, with respect to transformer, because this is a transmission line, no? Transmission line, before that transformer 1 is there. So whatever the base MVA value here, the same value you need to take for transmission line. So same value we are taking, that is 15 MVA we are taking for transform. So, sorry, for a transmission line. So, if you calculate, you are getting the Z base as 8.067 oops. So, Z per unit is equal to actual value divided by base value. What is the actual value? That is 20 J divided by base value. What? Base value already we calculate. Actual value, it is given in the problem, that is 20 J. So, while simplifying, you will get the answer as Z per unit for transmission line. Z per unit new for transmission line, we can calculate it as 2.47 J per unit. Just tell in the comment whether you are getting the same value or not. Next comes the transformer 2, because in the that diagram, whatever given, next is transformer 2, the same values and also refer to HV side. So transformer 2, what? The same thing, once again we need to calculate, or otherwise we can take the same value also, but we can calculate. If you calculate, you can understand better. So Z per unit given is equal to Z actual divided by Z base. So Z actual, instead of Z actual, they have given us reactance. So reactance value we are taken as 15J divided by base value. Okay, so that we are taking. So that is base value we need to calculate. The base Z base equal to base KV squared divided by base MVA. So with respect to HV side, base KV squared is nothing but 33 squared. Okay, 33 KV squared divided by 33 squared divided by 50. That is base MVA is 15 MVA. Okay, 15 MVA already given in the transformer rating. Okay, that same rating we are taking here. So while simplifying, we are getting the Z base value as 72.6 ohms. Next, Z per unit given equal to Z actual by base. Actual is J 15J divided by base value, whatever we calculated is 72.6. So we are getting the answer as J into 0.2. That is if we are taking the primary side. Next, when we are considering the on the that is on with referring to HV side, the same we consider as a low voltage side. If you take the same thing as low voltage side, so Z base is equal to base kilovolt square divided by base MVA. So low voltage side, what? Because 33 by 11, no? Here we are taking 11 square. Okay, 11 square divided by base MVA same. That is 15. So Z base is equal to 8.067 ohms. So Z actual is equal to Z actual is equal to 15J divided by A square. So A square is a transformer ratio. So transformer ratio what? 33 by 11. So 33 by 11 the whole square. So if you calculate this, you will get the value as 1.67 J. Next, Z per unit given is equal to Z per unit actual divided by Z base. So actual what? J into 1.67 divided by base what? 8.066. So if you calculate it, you'll get the answer as 0.2 J. So here also 0.2 J, here also 0.2 J. Already we have seen the significance of per unit. In that itself, we just make a note. In that, we just made a note like a per unit impedance of either the side of the transformer is same. That is the note. So that video also I will give in the description, that you please watch if you not able to understand this particular point. So that we already we have discussed in our previous class. So per unit impedance of the either side of the transformer is same. That is primary side and secondary side. So both side the per unit impedance is same for the transformer. That we have seen. Now we need to calculate the, so either you can calculate this side or this side, or will give you the same answer. Better you can go for the HV side, because we are referring to the HV side. Okay, if you consider LV side also, okay, no issues. The same answer will you will get. Okay, next Z per unit nu is equal to Z per unit given into KVB given divided by KVB nu the whole square into MVA base nu divided by MVA base given. So this you substitute. Z per unit given what we calculated, that is 0.2 J into KVB given, that is 33. Yes, 33 by 11, 33 divided by KVB new, we calculated as 31.5. Okay, 31.5. I think in the previous, like in the transformer one, we calculated. Okay, KVB new 33, 31.5. So same thing we are taking. So once again, if you want to do calculation, you do. Okay, same value will come. So 31.5 KVB new into given value is 15 MVA in the transformer rating. So 15 MVA taken, base value new value is 30 MVA. So just calculate it, you will get the 0.439 J. That is Z per unit new for transformer 2. Next comes the load. So in the load, what is the rating given? Yeah, load ratings are given as 40 megawatt and 6.6 kilovolt, comma 0.85 lagging power factor. That is clearly given. So for load, the ratings are given. So with the load ratings, we need to calculate the Z per unit. Okay, value, new value. So for the load, what it is given? Load, it is given as 40 megawatt. Okay, so you know P is equal to VI cos phi. So VI is nothing but S, that is the apparent power. So S cos phi. So S is equal to P divided by cos phi. So P is what? 40 megawatt. So 40 divided by cos phi is given 0.85 lakh. So same thing you substitute. So we are getting S. S is equal to 47 MVA. So similarly, cos phi is equal to 0.85 lakh means what is phi? Cos inverse of 0.85. You will get that pi is equal to 31.78 degree. So now we are taking the as minus. Why? Because it is lagging power factor they have given, mentioned in the problem. So lagging power factor means we are taking this minus. Now, Z load? Load is equal to base kV square divided by base MVA. So what is base kV square? 6.6. Okay, 6.6, that is given in the problem. So 6.6 square divided by, for load values it is given as 6.6. So the same load value we have taken, that is 6.6 whole square divided by base MVA, whatever we calculated. Here we have calculated as 31.78 and 47. Yeah, 47 is the that base MVA value. So 47 at the angle of minus 31.78. So that we are taking this base MVA. So while simplifying, you are getting the answer as 0.78 plus J into 0.488. Next, we need to calculate Z base. So same formula, Z base equal to base KV square divided by base MVA. So base KV squared is nothing but 3.66. 3.6 is how it comes, means KVB based on LV side is nothing but 11 kilovolt. So 11 divided by A, transformer ratio A. So transformer ratio A is 11 divided by, so we are referring the HV side, that is we are referring to HV side that is given in the problem. So we have taken that value as A as 33 by 11. So 11 divided by 33 by 11. So A as transformer ratio 33 by 11. So 11 into 11 by 33 is the 3.66. That 3.66 we are taken here. So 3.66 whole square divided by base MVA. So base MVA already given in the problem as 30. So now we are calculating the, here base MVA is with refer to the problem, that is from the generator. But when comes to the load, base MVA load, whatever we calculate, that we need to take. Don't confuse between the load and base values. Okay. So here 30 MVA. So here Z base, while calculating, you are getting the answer as 0.466. Okay, so now Z per unit nu is equal to Z load divided by Z base. So load value already we calculated, that is 0.78 plus J into 0.48. Yeah, this value divided by Z base value 0.466. So Z per unit is equal to, so when you simplify this, you will get the answer as 1.748 plus 1.094 J. So you just tell in the comment whether you got the same answer or not. Now we need to draw the, this is for load. Okay, Z per unit nu for load value. Okay, so now we need to draw the impedance diagram. Already they said. Okay, draw the impedance diagram. So impedance diagram for generator already we calculated for generator J here. Yeah, for generator Z per unit nu for generator is J 0.435 per unit. For a transformer 1, Z per unit nu for transformer 1 is 0.439 J. Just highlight the final answer. So it is easy for the evaluators to evaluate your papers. Okay. Next, for a transmission line, yeah, Z per unit for transmission line is 2.7 per unit J. Next for a transformer 2, also we calculated, that is 0.439 J. Next for load also we calculated as a yeah, 1.748 plus 1.094 J. That is R plus this is reactance part. So now we are drawing with the generator, yeah, J into 0.435, and for a transformer 1, 0.439 J. Next, for transmission line 2.47 J. Next, for transformer 2, it is 0.439 J. Next, for load, because these two values are same. Why? Because we taken the same values with refer to primary side and secondary side, with refer to HV side we have taken, and the values also, the problem same is given. So same impedance, like impedance value we got. Next, here for load it is 1.748 plus the reactance value is 1.094 J. So like that you need to draw. So you need to clearly understand the problem and you need to solve the problem. That is more important while solving the problem. So this is the impedance diagram for the problem given. Okay, this is the problem. This is the impedance diagram for the problem given. We have solved. Thank you.